Questions from the committee? Any questions from the committee?
Just very quick question on slide 70, you were showing the LED turns on, I think, with 40 milliamp and with some decent voltage. I wonder how long you kept it on, and is there any problem related to heat generation there? That was a decent current, looks like your setup can handle, or decent power. Go to 770.
77 or?
No, 70.
70.
Okay. Oh, okay. So
yeah, this one. Yeah. So here, let's see. We are seeing 5 volt times 50 milliamp. That's a lot. That's like 250 milliwatt with some efficiency. Obviously, it radiates, but that's a decent heat generation. So, did you have any problem keeping it on for a long time? Did it cause any damage, or it was okay?
no, it was okay. And also in this step, actually, we would like quickly test the device because this is just for the stamping process. So,
okay. Yeah, that's good.
You don't need this kind of driving current for normal.
Yeah, if we just, I mean, here at this step, the only reason we would power the device is to test them, right? And we would test them at, we wouldn't test them at such high currents. We would test them at like,
right. This is good, right? If your substrate can handle this, it just shows you can actually use a circuit that's 200 milliwatt in the same area, and your substrate can handle it.
Yeah, but I think,
yes.
Goutham, you should also mention that part of the voltage that you're using is because of the potential delamination issue, right? Normally, you wouldn't. Does this sample have that delamination issue?
Yeah, you can see that.
Yeah. So that's why I think the delamination causes an increase in the series resistance of the diode, and so you have to, for the same current, you have to apply a much larger voltage. If the process was, we had good LEDs that had very low contact resistance, I suspect that the voltage required would be probably at least 1/3 or so. I don't know what the number is, but Goutham.
Yeah. Yeah, in this case, like, so some of the contacts were preserved. So they were actually tested in those places where the contacts still worked. So this is, yeah, in some places the contacts delaminated, some places the contacts were fine. So, so this particular comparison was done in those places where the contacts were still working.
Chivi, you have a question?
Just a quick question. Very nicely done work, Goutham. Have you thought about thermal cycling and mechanical cycling? I think the committee asked this in various fashions throughout your defense.
Yes. So mechanical cycling, yes, we have done mechanical cycling. Like we typically do, once we make our samples, we typically do like a bending cycle test, like several thousand bending cycles, and we check whether our interconnects have any degradation in resistance. So for the display itself, I have not yet done the mechanical studies to see whether the display quality changes as I mechanically bend it. So with respect to thermal studies, we have not done any significant thermal studies to try, but that is definitely a key problem to this because the PDMS does not conduct the heat. So we need to somehow figure out essentially what is the maximum power density we can operate these devices at reliably.
So Goutham, you may want to refer to Arsalan's work where he has done JEDEC mandated thermal cycling and high temperature storage and things like that.
Yes,
So
So actually, Arsalan, one of my colleagues, Arsalan, has done more like reliability studies on FlexRate itself. The FlexRate, not particularly the display, but the FlexRate platform itself, studying things like humidity endurance and mechanical endurance and temperature cycling and so
on. Okay, thank you.
Thank you.
Hi, Goutham. This is Amir. Actually, very impressive work and excellent presentation. I was going to say, I actually had a question that I've been curious about. About your nickel is relatively brittle, relative to gold and copper. And you're plating somewhere between 5 to 10 microns on top of maybe a 50 micron LED. So if you think about maybe CTE mismatch between the nickel and the underlying structure, and as you're doing your final nickel etch, would you imagine that that could have played into your final DLAM? Because adhesion to the underlying substrate might not be as yeah. So could that have been the Achilles heel of why the micro LEDs have, or why your contacts did not survive this process?
So in this particular, yeah, that's actually a good question. So we actually did do studies on like singulating the device using different materials to see if the nickel was the cause. So in the 77 slide, right, where you see the contacts delaminating, here actually resist was used to dry etch the UPN, not the nickel. So even when using a low Young's modulus material like resist, the contacts still delaminate.
Okay, thank you. That's just, and the other question I'm wondering about, and this is so recently with Apple releasing the mini LED and all of the more interest, let's say, in commercial LED applications, I think one of the reasons for the super high cost is the not being able to rework some of these processes, meaning some of the transfer processes. Do you think there might be a way where you can have an adhesive that could allow for reworks, meaning that if you didn't have a very good transfer in the first step, maybe being able to come and rework one particular spot? I think this way you can actually have a commercial process that could basically have workarounds, where if you don't have a good transfer from the first time, you can potentially rework it. I'm just wondering if FlexStraight could be a good solution for this going forward.
Yes. So I think reworking on after assembly on FlexStraight could not be possible, because once the micro LED is embedded inside the PDMS, I see no way by which we can reliably remove it and then replace it somehow. But on the stamp itself, possibly we can do like a programmable laser debonding to like maybe release.
So Goutham, this is a very, very important point that Amir has raised, right? And you may want to talk about the work we've kind of proposed to do on testing at every step, you know.
Yeah.
There are, so Amir, your question is actually a very good one, which is actually quite also a troubling one, you know, in some sense, right? And so the key there is, you know, how do you know? You can't do rework once, you know, and I mean, you know this, you're a FlexStraight guru yourself, right? You can't do rework once everything is embedded, correct? So you had to figure out what not to bond, okay, before, what not to embed before you embed.
Right.
And so one needs to have a process, okay, whereby you can actually test these LEDs at every step in the process, right? And some places, right, you don't even have electrical contacts, right? So you have to do optical kind of testing, maybe luminescence or something of that sort, that will allow you to kind of reject, you know, areas where things don't work out fine and not embed those, right? So unfortunately, we have not had time to develop those concepts further. But although Goutham has, and you know, Henry actually.
Yeah, we have a patent we submitted about this.
We have a patent, but we
awesome.
haven't.
Thanks again, Goutham, and thank you, Subbu.
And thank you, Amir, for coming. I'm so glad to see you here.
Same here.
Sam, you have not asked anything.
I think from technical side, I'm fine. I think just want to say thank you for a great talk. I think the biggest problem you had to encounter in your PhD seems to be how to package all your results in a coherent 1-hour talk. And I see you went to 70 slides, so I think it was great to see you have such a productive PhD. I was also on Arsalan's committee, and I see that you guys are synergistically addressing different aspects of this FlexStraight technology. And I think that speaks very highly of Subbu, as well as putting together such a productive team and going after establishing this technology. So glad to be a part of the committee.
Thank you.
Thanks, Sam. The floor is open, and I'm going to do it this way. First, I'm going to ask the people in the house questions? We're all scared of you. And from the gallery, the Zoom gallery, any questions? Okay, in that case, what I'm going to do is I'm going to kick everybody out of the room. Okay.